I'm going to introduce a new concept called differentials, which is going to be used for the most important integration technique, no matter in calculus 1 or in calculus 2. Okay. Definition of differentials given copy the definition. Okay. Differentiable function I'm going to use u to denote the dependent variable. I'm going to use x to denote the independent variable. For the purpose you are going to see very shortly. Now let's say u equals f of x the differential of u of the function u. The notation is du, so denoted by du is defined as the following formula will give you the definition of the differential of u. It's denoted using du. Okay. So du is equal to the derivative of the function f of x and then times dx. For this one, you can treat du as a function of two variables, x and dx. By that, I mean each value of du is dependent on a particular value of x and a particular value of dx. Now for question 1, the function in the question is sine of x. In order to compute du, I will write a little bit longer solution. So du is computed using, all we need is to differentiate the function, to differentiate sine of x, and then you multiply the derivative by dx. To get the final answer, you need to get rid of the derivative notation. You need to evaluate the derivative. Okay. So the answer is cos of x and then times dx. Again, it's okay to treat the definition as a symbolic definition for now. Okay, that's the answer for the differential of u. We call the answer cos of x times dx is the answer to the differential of u. It's denoted by du. Okay. The second question, very similar, right? For the second question, I'm just going to write the answer in one step. Okay, so du is computed using, you look at question 2, du is computed using the derivative of cos of x, which is negative sine of x, and then times dx, so do not forget dx. The derivative of cos of x is negative sine of x, so the answer to question 2 is du, the differential of u, is negative sine of x dx. And then for question 3, it's the same thing. We'll get the answer in one step. Right? For the answer, for the differential of u in question number 3, I mean the differential of the function in question number 3 is denoted using du. To compute du, you differentiate the function. Okay, you take the derivative of the function, which is 2x, right? 2x, and then compute it, and then times dx. After we learn differentials, we're ready to talk about the substitution rule. The substitution rule is probably the most important integration technique in calculus 1 and in calculus 2. we mentioned before, integration is a reverse operation of differentiation. Each formula in differentiation will correspond to a formula in integration. The substitution rule is actually the integration equivalent of the Chen rule in differentiation. If you can see how important the Chen rule is, the importance of the substitution rule is the same. Now we talk about the substitution rule. I do not even give you the basic formula for the substitution rule. I just want to write when to use. So copy this down. Okay. So check two conditions. The first condition is that the integrand is the product of two functions. The second condition is that it is possible to choose u as a function of x. To choose u to be a function of x. So after that, the integrand is the product of two functions. We call them two factors. Such that one of the two factors, one factor, will become a function of u. With simple to find. Can I make this one word? Simple to find. Antiderivative with a simple to find antiderivative. In terms of u, of course. And the integrand has two factors. One factor, after choosing u property, one factor will become a function of u with easy to find antiderivative. And the other factor is the derivative of u times a constant. Multiplied by a constant. If the two conditions are satisfied, then it's possible to use the substitution rule to evaluate the integral. We're going to illustrate how to use the substitution rule using many questions. You look at the question on the screen. You look at the integral on the screen. The first thing I want you to realize is that the integrand is the product of two functions. I'm going to underline the two factors. The integrand is the product of two functions. One function, one factor is sine of x, the whole thing cubed. Okay. The other factor is cos of x. Okay. The integrand is the product of two functions. Check that. Okay. And then you check, is it possible to choose u to be a function of x such that one function is going to be a function of u, will become a function of u with easy to compute antiderivative in terms of u, and the other function is the derivative of u times a constant. Anybody want to guess how to choose u? No. Actually, the key is how to choose u. So choose u to be a function of x, so that one factor is going to be a function of u with easy to compute antiderivative. The other factor is the derivative of u times a constant. Okay. It's too early to ask you questions. I will show you the meaning. Okay. For this question, if you choose u to be sine of x, for this question, I'm going to tell you how to choose u. Okay. If we choose u to be sine of x, then one of the two factors, then sine of x, the whole thing cubed, will become a function of u cubed. Okay. U cubed has easy to compute antiderivative, right? We know a antiderivative of u cubed in terms of u. At least at this point, you can recall for any power function, we have a handy formula to get antiderivative of any power function, right? Again, I want to repeat, I choose u to be sine of x because one factor, the underlined factor, becomes a function of u cubed. U cubed has easy to compute antiderivative, has easy to find antiderivative. We have a handy formula to get antiderivative of u cubed. Antiderivative of u cubed is actually u to the power 4 over 4, right? So that's a particular antiderivative of u cubed. So u cubed has easy to find antiderivative. Okay. How about the other factor, the double underlined factor? I told you to check two conditions. Is it possible to choose u so that one factor will become a function of u with easy to find antiderivative? So that's one of the two conditions you have to check. And then the other condition, is the other factor the derivative of u times a constant? You look at u again. Okay, u is sine of x. The derivative of u. Now, the derivative of u is cos of x, which is the other factor, the double underlined factor. So I'm going to check that. Okay. Okay. Now I'm going to repeat the two things you need to check. Okay. One thing is, okay, the key is how to choose u. Now the thing you need to check is it possible to choose u to be a function of x? In this particular case, sine of x, satisfying the two conditions. Okay. The first condition is that the one factor will become a function of u with the easy to compute antiderivative. So that's u cubed. The underlined factor becomes u cubed, right? And then the other factor is the derivative of u times a constant. In this particular case, the other factor, cos of x, is just the derivative of u. That's why we choose u to be sine of x. Okay. I told you for now listen to me. The key is for any integral, if it's possible to use the substitution rule. Okay. The key is how to choose u. As long as you can choose u properly, then all the questions are essentially the same. Okay. And then I'm going to follow the standard step procedures to compute the integral. Okay. Now we are using the substitution rule to evaluate the integral. Now the solution. I told you how to choose u already, right? We let u be sine of x. In most cases, so do not make u too complicated. Okay. It's always the same. The next thing you do is to compute du, the differential of u. We just mentioned du, right? So then du. To compute du, we just mentioned du is computed using the derivative of u, okay, and then times dx. In this particular case, du is the derivative of sine of x, so which is cos of x, and then times dx. Okay. After choosing u property, the first thing you do is to compute du. Okay. After computing du, the next thing we do is to rewrite the integral entirely in terms of the new variable of u. So that's why we call it the substitution rule. Okay, the integral of x is going to be converted to a new integral of u. Okay. So in next step, we are going to rewrite the given integral entirely in terms of u. So the given integral, I'm going to copy the given integral. Equals, copy the integration notation, okay, integration notations, and then we are going to rewrite everything in terms of u. We are going to rewrite everything in terms of u. By that I mean you do that in one step. In the new integral, I do not want to see x. Okay. Now you look at the underlined factor. Okay, the underlined factor will become u to the power of 3. Is that right? Sine of x is u. Sine of x, the whole thing cubed, is u to the power of 3. Okay. And then you look at the whole thing in the box. You treat the box, you treat the whole thing in the box as a whole. You treat cos of x times dx as a whole. Actually, in most cases, we treat cos of x times dx as a differential of some function. Okay. You look at the box. The box is actually here. The box is actually here. So do you see the box? Actually, in most cases, you're going to see it. You're going to see y very shortly. In most cases, I want you to rewrite the whole thing in the box in terms of a number times du. If it's possible to use the substitution rule to evaluate the integral, it's always possible. I'm trying to say, in the next step, I'm going to write the whole thing in the box in terms of a number times du. So in this particular case, the whole thing in the box is cos of x and then times dx. Now I want you to treat the whole thing in the box as a number times the differential of something, of some function. In this particular case, it's just du. Okay. If you treat cos of x times dx as a whole, and then cos of x times dx can be replaced with du. So do you see what's going on? We are done the substitution. Now the new integral is entirely in terms of u, right? At this point, all we need is to rewrite the integral to evaluate the new integral of u. Okay. Using the power rule, you can get your phone. Okay. You need all the basic formulas. I told you to take a picture last time. I even told you to memorize all the basic formulas. Okay. For this one, we use the power rule for integration. Okay. It's a particular case when n value is 3. So you use the formula. You have u to the power 4, right? 3 plus 1. On denominator you have 4. You have n plus 1, right? And then plus c. After getting rid of the integration notation, do not forget to plus c. Okay? Do not stop here. In one more step, we're done. Okay? The given integral is an integral of x. In the final answer, you need to write the final answer as a function of x and then plus c. That's what I'm trying to say. Okay? The relation between u and x is always here. The relation between u and x is always the substitution you made in the first step. I'm trying to say in the final step, replace u with sine of x. You can write the final answer in the form of sine of x to the power of 4. This means u to the power of 4. It means sine of x, the whole thing to the power of 4, right? Over 4 and then plus c. I told you earlier, essentially all the questions are the same, as long as you can choose u properly. The key is how to choose u. I want to repeat, the key is how to choose u. The condition is that the integrand is the product of two functions, okay? And then how to choose u? If it's possible to choose u to be a function of x, in this particular case, choose u to be a function of x, such that one of the two factors is a function of u, with easy to find antiderivative. U cubed has easy to find antiderivative. You see, we need the antiderivative of u cubed in here, right? And the other condition you need to check is the other factor. The other factor is the derivative of u times a constant, multiplied by a constant. Okay. If you can do that, if you can choose a u satisfying the two conditions, then you can use the substitution rule to evaluate the integral. So that's question A. Probably I can do question B on the same slide so that you can do a comparison. Question B is actually very similar to question A. So anybody want to tell me how to choose u? So just write in the chat how to choose u, please. I told you the key is to choose u properly. Okay. If you can choose u properly, then all the questions are essentially the same. Anybody want to tell me how to choose u? This one should be simple. Don't make u too complicated. Okay. Choose u to be a simpler function of x. Yeah, choose u to be cos of x. Good. Thank you. If you choose u to be cos of x, the same story, then one factor is going to be u cubed, right? The other factor is not the derivative of u, but it's I will show you what's going on. Okay, I will show you why we can choose u to be cos of x. For this function, if you choose u to be cos of x, and then one factor will be the underlined factor will become u cubed, right? I'm trying to say cos of x, the whole thing cubed will become u cubed. U cubed has easy to compute antiderivative. And then now let's check the other condition. Is the other factor is the double underlined factor the derivative of the function times a number? The derivative of u is actually the derivative of cos of x is negative sine of x, right? It's negative sine of x. It's not sine of x. It's a number -1 multiplied by the derivative of u, right? So it's also permissible to choose u, so to be that way. Okay, I'm going to repeat the two conditions again. Choose u properly so that one factor will be function of u with easy to compute antiderivative. That's u cubed. One factor becomes u cubed, right? U cubed has easy to compute antiderivative. The other factor is the derivative of u times a number multiplied by a number. In this case, it's the derivative of u multiplied by -1, right? So that's why we can choose u that way. Okay, the comparison, okay, side by side. The solution, I will do the solution to this one for you too, okay. Later on, I will give you a chance to try some questions, but for this one, we'll let u be cos of x. So don't be confused. When we do the substitution rule, we need the derivative. We also need the antiderivative. So don't be confused. Okay. So basically, when evaluating the integral, you need antiderivative. When you compute the differential, you need the derivative of the function. Okay. I told you as long as you choose u properly, then all the steps are the same. Then all the questions are the same. I'm trying to say, okay. And then du equals you take the derivative of cos of x. You have negative sine of x. The derivative of cos of x is negative sine of x. So don't be confused, okay? The antiderivative of cos of x is sine of x. And you have that in the new formula. Okay, so the second step we do is always to compute the differential of u. The next thing we do is the next thing we do is always identify the differential in the given integral. In the given integral, we put. Can I tell you the rule of thumb? In the integral, we put. Okay, the integrand has two factors. One factor is going to be a function of u with easy to compute antiderivative, right? The other factor, you put the other factor, so together with dx, you put the two things in a box or imaginary box, of course. Okay. When you show your work, you do not need to box the product of two things. Okay. Okay. You imagine the other factor, so together with dx is in the box, and then what you do next is to treat the whole thing in the box as a number times the differential of u. You want to do that, okay? The whole thing in the box, you identify the box, okay? The box is always the other function times dx that's in the box. And then if you can choose u properly, you can always identify the box in the differential of u. So do you see in the differential and in the given integral, the two things in the box are the same, right? The next thing you do is to solve the equation for the box. By that we mean we want to write the other function times dx as a number times the differential of u. Okay, I will show you the meaning. Okay, the whole thing in the box, is sine of x and then times dx. I still keep the box. Okay. If you can choose u properly, then the whole thing in the box can also be written, can always be written as a number times du. By that we mean we can always treat the whole thing in the box as a number times du, a number times the differential of u. It's negative du, right? You look at the mouse cursor. From here to here, all we need is to multiply two sides of the equation by -1. Okay. At this point, you are ready to write the given integral in terms of a new integral of u. At this point, I do not want to see two variables in one integral for a reason you are going to see. So maybe next week. In any case, I do not want to see two variables in one integral. I'm trying to say I do not want to see x and u in one integral. So do not do that. Okay. What I'm trying to say is, in next step, you write the whole thing entirely in terms of u without showing x. The first factor is u cubed, right? U is cos of x. Now the first factor is cos of x, the whole thing cubed. The first factor is u cubed. That's in terms of u already. Okay. And then you identify the box in the given integral. Okay. In the box, you have the other function times dx. This one is, we have seen that in the last step. So which is so negative du. But negative du can be treated as -1, so times du. It's permissible to leave out a constant out of the integration notation. We have seen that last time. Okay. I'm trying to say, in most cases, if you see a number times so negative, I'm trying to say if the whole thing in the box is negative some number so times du, it's permissible to leave the negative sign out of the integration notation. Okay. At this point, we can evaluate the new integral of u, right? So you have negative antiderivative of u to the power of 3 is u to the power of 4 over 4, right? And then plus c. After getting rid of the integration notation, so do not forget to plus c. And then finally, return to x. Write the final answer in terms of a function of x, then plus c. U is cos of x, so you have negative cos of x, and then the whole thing to the power of 4 over 4, and then plus c. Okay. You see, a slightly new thing is actually in here. So du is not the other function, so times dx, but du now is a constant, a number times the other function, so times dx. I'm trying to say du is a number times the whole thing in the box. In this case, you solve the equation for the box. You treat the whole thing in the box as a whole. Okay. By doing that, you can rewrite the integral entirely in terms of the new variable of u. Any questions so far? If you don't, I'm going to move on to question number 2a. So did I tell you the substitution rule is the most important integration technique? Actually, in calculus 2, if you do calculus 2, you are going to see many more techniques for different types of the integrals. But in any case, the substitution rule is always the most important technique for integration. Or you can say the substitution rule is the most important integration technique. For this one, so before you can see how to choose u properly, I'm going to rewrite the integral in slightly different form. It's the same as the integral, okay? The given integral, I mean. I'm going to rewrite the integral in slightly different form so that it's easier for you to see how to choose u, okay? So basically, I just want to switch the two factors. One factor is e to the power of x squared. The other factor is x, okay? And then times dx in here. I will remind you how to choose u. Okay, choose u so that one factor, the integral now is the product of two functions. Is it possible to choose u so that one factor is a function of u will become a function of u with easy to compute antiderivative, and the other factor is the derivative of u multiplied by a constant? Do not make u too complicated. Anybody want to tell me how to choose u? The key step is how to choose u. If you can choose u properly, then all the questions are the same. Anybody want to tell me how to choose u? So just guess. I know you haven't been doing too many questions using the substitution rule, but try something, please. Choose u so that one factor will be a function of u with easy to find the antiderivative. The other function is the derivative of u multiplied by a constant. Anybody want to tell me how to choose u, please? Anybody want to try? It's okay to write something wrong. That's why you are here, so that's why I'm here. Anybody want to try to tell me how to choose u? So just remember one thing at least, okay? How to choose u so that the first factor will become a function of u with easy to find the antiderivative. Let u be something x, so please. Try again. X squared is good. Yeah, we choose u to be x squared. So why we choose u to be x squared? After choosing u to be x squared, then one factor, the underlined factor, will become e to the power of u. So that makes sense. And we know antiderivative of e to the power of u. I do not want to box that. I'm going to use the box to represent other things. Okay. One factor, choose u to be x squared. So one factor will become e to the power of u. And the e to the power of u has easy to find antiderivative. Antiderivative of e to the power of u, you look at the basic formulas, is e to the power of u, right? So how about the other factor? The other factor is the derivative of u times a number. If you take the derivative of u, you have 2x, right? Which is 2 times the other factor. So that's why we choose u to be x squared. You're going to see what's going on. Okay, choose u to be x squared, and then if you choose u properly, then all the questions are the same. Okay, the next thing we do is to compute du. It's always the same. We compute du. So don't be confused. We differentiate the function. We take the derivative of the function of x and then multiply that by dx. Okay. The derivative of x squared is 2x, right? 2x and then times dx. That's how we compute the differential. I told you that at the beginning of the class. Okay. Alright. And then what you do is to identify the box. So basically you box the other factor, so together with dx. You want to write the whole thing in the box as a number times du. So that's what you want to do. Okay. After computing du, after getting the differential of u, identify the box in the differential of u. Okay. And then solve the equation for the box. It's always the same. You do that, so because in next step you are going to convert the integral of x to a new integral of u. So that's why you want to do that. Okay. In order to solve the equation for the box, you divide two sides of the equation. You look at the mouse cursor. You divide two sides of the equation of that by 2. So you have 1/2 of du. You have 1/2 of du. If you choose u properly, then the whole thing in the box can always be written as a number times bu. If you can achieve that, then you have chosen u properly. So that's how you check. Have you chosen u properly? Okay. Now we're ready to convert the new integral entirely to a new integral of u. Now the given integral is equal to, so how about we just use the other form as with the two factors. So it doesn't matter. I'm going to copy. So e to the power of x squared, and then times x, and then times dx. I did nothing but copying the or rewriting the given integral in a different form. I switch the location of the two factors. Okay, now we're ready to convert the integral to a new integral of u. Do not include two variables. Always write the new integral entirely in terms of u. Okay, x squared becomes u, right? So one factor becomes e to the power of u. So this factor has easy to compute antiderivative, right? Now the whole thing in the box, is half of du. You write du after the function of u, and then you leave the constant 1/2 out of the integration notation, right? Again, we mentioned the last time it's permissible to leave a constant factor out of the integration notation. Okay, now we're ready to evaluate the integral, so which is simple, right? So this thing is 1/2, and then times e to the power of u. I mean, antiderivative of e to the power of u is e to the power of u. Okay, after getting antiderivative of e to the power of u, and then you plus the constant of c. Finally, write the final answer in terms of x only. Okay, it's 1/2 e to the power of u as x squared. Again, the relation between u and x is always from the substitution you made in the first step. You replace u with x squared, and then you plus c, so you have the answer. Any questions about this? I should have done that for the first question, but in the future, I told you last time, for any indefinite integral, it's always possible for you to check the answer on your own. By that we mean the answer to an indefinite integral is always a number. Sorry. Now let's try again. The answer to an indefinite integral is always a function plus c. Okay. How to check the answer? Is right or not? You differentiate the function. If the derivative of the function is the same as the integrand, and then your answer is right. Now let me try to verify that. It's not part of the solution, but I'm trying to say for the final exam or the assignment, now suppose you have time, it's always possible to check the answer on your own. Okay. We differentiate the function, we compute the derivative of 1/2 times e to the power of x squared. You have to use the chain rule. Okay. So because the substitution rule is the integration equivalent of the chain rule. You leave out the constant of 1/2, and then you differentiate e to the power of x squared, right? And then for this one, you need to choose u, right? the inside function is x squared, you differentiate e to the power of the inside function u. Okay, so you have 1/2 of the derivative of e to the power of u is e to the power of u. It's e to the power of u. You do not write u, you write the answer as e to the power of x squared. You are not done yet. You need to differentiate the inside function. You differentiate x squared, so you have 2x, right? 2 and 2 is cancelled. So you see the answer to the derivative of the right hand side is equal to x times e to the power of x squared. So your answer is right. Okay. I was trying to tell you it's always possible to verify the answer yourself. Okay. Again, this is not part of the solution. I do not want to leave it here. Any questions? B and C are similar, so maybe later on I will give you a chance to try B and C, but I want to show you a more complicated one. So maybe some question D. I want to go over question D now. For this one, I'm going to rewrite the integral in different form. I'm trying to say I'm going to switch the two factors of the integrand, so that it's easier to choose u. So one factor is going to be cos of 5 of x to the power 4, and then the other factor is x cubed, dx. Okay, so anybody want to tell me how to choose u? To think how to choose u, always look at the complicated factor, and do not choose u to be the whole thing. Choose u to be a function of x, so that the more complicated factor will be a function of u with easy to find antiderivative. Anybody want to tell me how to choose u? Anybody want to tell me how to choose u? Don't make it u too complicated. Yeah, that's right. Yeah, that's right. I told you to think about how to choose u. Look at the complicated factor. Okay, look at the underlined factor. So do not choose u to be the whole thing. Choose u to be a function of x, a simpler function of x, so that the factor has easy to compute antiderivative. If you choose u to be the whole thing, so in the brackets, and then the underlined function will be a function of u, will become a function of u as cos of u. We know antiderivative of cos of u, right? And then you check the other factor. The other factor is the derivative of u times a constant. The derivative of 5 times x to the power 4 is probably 20 times x to the power 3. It's a number times the other factor. So that's why that will work. That u will work. Okay. Again, if you choose u properly, then all the questions are the same. Now the solution. We let u be, so Brooke told me it's 5x, so to the power 4. We mentioned y, right? And then you follow the routine. The next thing you do is always to compute du. So don't be confused. Du is the differential of u. To get the differential of u, you differentiate the function times dx. Okay. The derivative of 5x to the power 4 is 20 times x to the power 3, right? So dx. So do not forget dx when you compute the differential. The differential of u is always the derivative of u in terms of x. It's 20x cubed, and then times dx. So do not forget dx. Okay. At this point, identify the box from the given integral, the other factor, so together with dx, okay. And then identify the box from the differential. The next thing you do is always to rewrite the whole thing in the box. You treat everything in the box as a whole. Okay. You solve the whole thing in the box in terms of a number times du. If that's possible, then your u is good. Okay. So we have x cubed and then times dx, the whole thing in the box, right? Is equal to, you divide two sides of the equation by 20. I think you have 1 over 20. You have 1 over 20 and then times du. Okay. You see the whole thing in the box. The box is here. The box is here. The box is here. The whole thing in the box now is written as a number times du. If you have chosen u properly, then it must be true the whole thing in the box is a number times du. Okay. Otherwise, you need to do some other. You need to use some other techniques or choose some other use. At this point, we are ready to rewrite the integral entirely in terms of u. Okay. I use I to denote the given integral, so I do not have to copy everything. At this point, the integral I is equal to, do not write two variables in one integral. Okay. The new integral is going to be entirely in terms of u without any x in it. Actually, when we talk about the substitution rule for the definite integrals in next week, you're going to see why. Okay, everything in terms of u, it's the underlined factor is going to be a function of u as cos of u, right? We know how to get antiderivative of cos of u. By that we mean we know which function has the derivative of cos of u. Okay. And then the whole thing in the box is 1 over 20 and then times du. You can leave the constant factor out of the integration notation. It's 1 over 20, right? And then times du. You see the given integral of x is pretty complicated, and after the substitution rule, after writing the new integral of u, this new integral of u is manageable. Actually, it's in the basic formula, right? You copy 1 over 20, the constant, right? And then you look at the formula sheet. You have a formula for getting the antiderivative, to getting an antiderivative of cos of u. Look at the formula for the indefinite integral of cos of x. Antiderivative of cos of u in terms of u is sine of u, right? And then plus a constant c. After getting rid of the integration notation, so do not forget to plus c. Okay. Finally, the final answer in terms of x. The final answer should be in terms of x. Okay, it's 1 over 20 sine of wherever you see u, you replace u with the 5 times x to the power 4, and then plus c. Okay. Of course, it's possible to verify if your answer is right by differentiating the right hand side. I mean the answer to the integral. If the derivative of the right hand side is the integrand, then your answer is right. Simple. Okay, so that's that. Any questions? I will do 2 more questions, so before we take a little break. Okay. Now question 3b. For this integral, it doesn't look like the integrand is the product of 2 functions, but you can always treat 1 as one of the 2 factors. Anybody want to tell me how to choose u for this one? Anybody want to tell me how to choose u? Look at the integrand. Do not choose u to be the whole thing. Choose u to be a simpler function of x, so that one factor as a function of x has simple to find the antiderivative. Anybody want to tell me how to choose u? Let u be. Yeah, 2x plus 5. 2x plus 5 will work. Let's see what's going on. Okay, 2x plus 5. The next thing we do is always to compute du at this point, so don't be confused. The antiderivative and the derivative. To compute the differential of du, you need to differentiate the function. Okay, the derivative of 2x plus 5 is the constant of 2, so you know that, right? 2 times dx. And then after that, you identify the box. No matter how simple or how complicated, it's always the same. Okay. The other factor, which is 1, so times dx, you treat that thing as the whole thing in the box. Okay. What you do next is to identify the box from the differential, and then solve the equation for the box. You know what's going on, right? If the whole thing in the box, you'll see the boxes here, here, and here. Everything, the box in the 3 places are the same. If you can write the whole thing in the box as a number times the differential of u, and then your u is right. Okay. By that we mean it's possible to use the substitution rule. Now your next job is to rewrite the given integral entirely in terms of u, so without involving any x. I know even in our textbook, the author was trying to include x and u in one integral. I really do not like that. You're going to see the reason next week. So the integral now in terms of u, the underlined function sine of 2x plus 5 becomes a function of u as sine of u. Right. And then dx, the box becomes half of du. Alright. Now integrate the function of u. In the new integral, you have a integral of u. Integrate the new integral of u. We're almost done, right? Okay, you have half of. So don't be confused. Antiderivative of sine of u, you think which function has the derivative of sine of u? It's negative cos of u. Or you look at the basic formula. Antiderivative of sine of u is negative cos of u. Okay, so do not forget that it's negative cos of u. I put the negative sign here. Negative cos of u and then plus c. after getting a antiderivative, you plus a arbitrary constant of c. Okay. Finally, the answer is negative 1/2 times cos of. Now, where in the last step, you write the final answer in terms of x only. Okay. U, the relation between u and x is always in the first step. Okay. Wherever you see u, you replace u with 2x plus 5. And then plus c, you have the answer. So any questions about this? You see the key is how to choose u. Okay. As long as you can choose u properly, you see all the steps are the same. Identify the box. Okay. Compute the differential, identify the box, solve for the box, and then rewrite the integral entirely in terms of u. Right. Evaluate the integral of u, and then you return to x. That's everything. If you don't have any questions, then I will give you a chance to try some questions. I'm combining the break and the time for you to try questions. Now I want you to try. I will put the questions I want you to try on one slide. I think I did question B, right? So how about you do question D? For question B, I will give you some hint. Okay. In particular, how to choose u. For question B, if you rewrite the integral to a different form, I'm trying to switch the two factors. Okay. To the form of e to the power of negative 4x cubed, and then times x squared, and then dx. If you rewrite the integral in that form, it's easier to see how to choose u. I'm trying to say, for some questions, if you switch the locations of the two factors, then it's easier to identify u after doing that. Anybody want to tell me how to choose u for question B? Whatever B on. Anybody want to tell me how to choose u for this question? Please, let u be. For question B on the screen, how to choose u, please? Yeah, negative 4x cubed. And then for question C, we'll do the same thing. Okay, we switch the location of the two factors. You'll have one factor is sine of x cubed. I think in this case we'd better use some brackets, and then times x squared, and then times dx. For question C on the screen, anybody want to tell me how to choose u, please? For question C on the screen, anybody want to tell me how to choose u, please? Choose u so that one factor will be a function of u with easy to compute antiderivative. The other factor is the derivative of u times a constant. I think you have seen the idea already. Okay. Question C, how do we choose u? Choose u to be x cubed. Okay. Sure. So do not choose u to be the whole sine of x cubed. The underlined function is that I told you do not make u too complicated. choose u to be a simpler function, so that the underlined function has simpler to compute antiderivative. Choose u to be x cubed, so this one will work. And then for question D on the screen, so anybody want to tell me how to choose u? Choose u to be 2x plus 3. Okay. Now question B. I told you how to choose u already. Okay. Again, choose u properly so that one factor, the integrand is the product of two factors, so that at least one factor will become a function of u with easy to compute antiderivative. So that's why after choosing u to be negative 4x cubed, one factor will become e to the power of u. You know antiderivative of e to the power of u, right? And then the other factor is the derivative of u times a constant. Okay. After choosing u properly, you compute du. You differentiate u. Okay, differentiate u. The derivative of u is negative 4 times 3 x squared. So do not forget dx. Dx is part of the differential notation, right? And then identify the box at 3 places. The other functions, so together with dx as a box, right? Identify the box in the differential and solve the equation for the box. Treat the box as a whole. Okay. If the u you have chosen is correct, it's right, then the whole thing in the box can always be written as a number times du. Okay. And then what you'll do is to rewrite everything in terms of u. Antiderivative of e to the power of u is e to the power of u, right? And then you can have the answer. Any questions about this? I told you the key is to choose u. As long as you choose u properly, then all the questions are the same. It's just kind of filling blanks. Right? Okay, now question C. In question C, choose u to be x cubed. I told you before, for the same reason. Choose u so that one factor will become a function of u with easy to compute antiderivative. Choose u to be x cubed, and then one factor will be sine of u, right? The other factor is the derivative of u times the constant. After choosing u properly, compute du. The differential of u, okay? The derivative of u times dx, so do not forget dx in here, okay? And then identify the box at the 3 locations in the given integral, in the differential, and solve the equation for the box, right? After doing that, you can rewrite the given integral entirely in terms of u. Integrate the new integral of u, you have the answer. Any questions about C? Okay, now look at D. Actually, question D is very similar to question B or C I did. Okay. Choose u. I told you how to choose u, right? And then you compute du, the same thing. Identify the box at 3 locations, and in the last location, solve the equation for the box. If the whole thing in the box can be written as a number times du differential, then you have chosen u properly. And then convert the integral to a new integral of u. The antiderivative of cosecant squared of u is negative cotangent of u. Okay. And then you write everything in terms of x. Okay. The 2 questions we're going to talk about are in the nature that you need to manipulate the function, the integrand, a little bit before you can see how to choose u. Okay. In order to use that form, we want 1 at this location. In order to achieve that, we take out 25 from the denominator, or take out 1 over 25 from the whole thing. You're going to see what's going on the next step. on numerator you have dx, on denominator we wanted 1 at this location. After taking 25 out of the 2 factors on the denominator, you have 1 at this location, right? And then plus x squared, on denominator you have 25 in here. The reason is that I want 1 at this location because I want to use that formula to evaluate the integral. At the beginning, I see the 2 integrals are kind of in the same form. The only difference is 1. Okay, so that's why I want to use that form. I want to do the conversion. And then you have 1 over 25 in here. On numerator you have dx, on denominator you have 1 plus. The second term on the denominator, I'm going to rewrite the second term on denominator in the form of x over 5, the whole thing squared. I think all of you guys know this, as long as I remind you. At this point, we are ready to see the substitution. At this point, I'm going to give you the complete solution to this question. Okay. At this point, we can again, I want to use that formula. You look at the mouse cursor to evaluate so that integral. The answer to the integral of that is equal to inverse tan, right? Inverse tan of u and then plus c. I'm trying to say we have a handy formula for computing the integral. At this point, you want to set u to be x over 5. You see the integral is going to be kind of become you have 1 plus u squared on denominator, so that you can use this formula. Okay. And then we follow the routine. Okay. And then the next thing we do is to compute du. Du is the differential of u. You differentiate the function. You have 1 over 5 and then times dx. Okay. Now you kind of identify the box at 3 locations. Solve the equation for the box. Dx is equal to 5 times du. Okay. So your box is here, right? Sorry. Your box in this case is just dx. Solve the equation for the box. Right. So the given integral, can I just keep on writing from here so I do not have to copy everything? The given integral is equal to, you still have 1 over 25. And then dx now will become 5 times du. Do you see that? Dx in the box is 5 times du. Okay. And also on denominator you have 1 plus u squared. Now you leave the constant factor out of the integration notation. You cancel out 5. You have 1/5, right? And now on numerator you have du. On denominator you have 1 plus u squared. We have achieved what I wanted. So because originally I wanted to use that formula to evaluate the integral. Okay. And now we're ready to get the answer. So we have 1/5, and now we have inverse tan of u, and then plus c. Okay. Now the final answer is 1/5 times inverse tan of u is, so what's your u? U is x over 5, and then plus c. Okay. Simple. Again, a question like that is in the nature that in some cases you need to manipulate the integrand, the function, a little bit before you can see the substitution. We'll do one more question in that nature. For this one, it's kind of very similar to the other question. You look at the formula sheet. In the basic formulas, you have a formula for handling the integral of, let's say, I'm going to rewrite the integral in terms of u. Okay, on numerator you have du, on denominator you have square root of 1 minus u squared. So the integral of that is equal to, it's inverse sine, right? Inverse sine of u and then plus c. I'm trying to say, you see, the given integral is kind of in the same form of that integral. So just I want to make this for location 1. If I can achieve that, then we can do it, right? Okay, now the numerator is dx. I'm going to write dx on the numerator. Okay. Okay, now on denominator, I want this for location 1. I want to change this for location to 1. Okay, so we have square root of 1. We kind of take 4 out of the two terms. If we take 4 out of the two terms, and then we take 4 out of the radical notation, it will become 2. I'm trying to say it will become 1/2, and then you have 1 minus x squared over 4. I will try to do that in some more steps. Okay, in one more step, you have 1/2 in here on the integral of that, and then you have dx on numerator. On denominator, I'm going to give you one more step. On denominator, you have 1 minus x over 2 the whole thing squared. Okay. We did a So just when taking 4 out of the square root notation, it will become 2. Okay. All right. At this point, we can see the substitution we are going to need. Okay. Okay. At this point, we are going to see the substitution. Can I write the substitution here? So we let u be. Again, we want to convert the integral to that form. So that is the idea. Okay. So we want u to be x over 2, right? And then we follow the routine. We compute du. Du is 1/2 and then times dx. So differentiate the function and then times dx. Okay. So dx is 2 du. Do you still want me to identify the box at 3 locations? That's the box at 1 location. So that is the box in the differential. That is the box. Right? Solve the equation for the box. Okay. Now I will move back to the left-hand side and rewrite the integral to a new integral of u. Okay, you have 1/2, and on numerator, dx becomes 2 du. I can leave 2 out of the integration notation. Again, dx becomes 2 du. And then on denominator you have square root of 1 minus u squared. Okay. 2 and 2 is cancelled from the numerator and the denominator. Okay, so the antiderivative of 1 over square root of 1 minus u squared is inverse sine of u. You have inverse sine of u and then plus c. Thus, the answer to the indefinite integral in terms of u. That's not the final answer. For the final answer, you need to return to x. Write the final answer in terms of x. I will squeeze the final answer in here. It's inverse sine of u is equal to, where is it? Half of x. and then plus c. Okay. Any questions about this? The two questions we did are in the nature that we need to manipulate the function, the integrand, a little bit before we can see the substitution. Okay. The two questions are in the same nature. Okay, on the screen you have your new assignment. Probably the assignment number, I did not change the number. It's supposed to be number 10. Okay. In part 1, you have two questions. Each term is essentially a power function. I'm trying to make some comments on the assignment. Okay. Convert each term to the form of a number times a power function. Okay. Of course, you do not have to convert that for the term including pi. Pi is nothing but a number, a constant. Okay. And then you use the power rule to evaluate the integral. It's kind of in the nature of the question we did on Tuesday. We did in the last class. Question 2 is simple. It's designed for the basic formulas. I do not have any comments. All the questions in part 2 are designed for the purpose of the substitution rule. Okay. I will copy the question to the screen. Anybody want to tell me how to choose U for question 1 very quickly? For question 1, choose U to be, I think we have seen a few questions like that. Choose U to be 5x and then plus 6. Okay. So that one factor will become U to the power of 100. And that's a power function of U. You know how to integrate a power function of U, right? For question 2, I will tell you how to choose U. Okay. For question 2, choose U to be 2 square root of x and then plus 7. By that I mean choose U to be the whole thing in the brackets on the numerator. Okay. I will even give you du. Okay. For question 2, du is going to be, you differentiate u. So you want to recall the derivative of square root of x is equal to 1 over 2 square root of x. You can use that formula. Okay. So du is equal to, using that formula. Okay. So differentiate the function of u. I think you have 1 over square root of x and then times dx. That's probably enough hint. Alright. Then in question 2, your box is going to be the whole thing in that box. You can solve the equation for the box. Okay. Now for question 3. For question 3, choose u to be, it looks a little bit complicated. So, but if you choose u to be, now let's say 9 minus x squared, then the whole thing is going to be simple. Your box is the whole thing as I just circled. So just try that. If you have any questions, we could make more comments. Okay. For this one, the new integral of u is going to be kind of a number and then times on numerator you are going to have du, on denominator you are going to have square root of u. So do you know how to handle that? It's going to be a number times a power function of u as u to the power of, so negative 1/2, and then times du. I do not know the number, so before the integral, you need to figure that out. Okay. But I told you how to convert the function to the form of a power function so that you can handle it. That's for question 1, that's for question 2, that's for question 3, that's now question 4. In question 4, choose u to be 15 and then plus x cubed. So your box is x squared and times dx. That's for question 4. Okay. And then question 5, I will also tell you how to choose u. For question 5, I think you choose u to be, let u be the natural log of x. For question 5, I will give you one more step. Okay. And then you compute du. du is going to be the derivative of u times dx, right? The derivative of natural log of x is 1 over x, and then times dx. So do you see your box is here? Your box is also here, right? Any questions? You need to do some questions to get familiar with the technique. I mean the new technique, the substitution rule. I want to repeat, it's the most important integration technique in calculus 1, in calculus 2, and in whichever calculus.